Like I mentioned, these notes will serve us for 2 days. Today is more of an introduction day. We need the skills we'll get today to be able to do the rest of the lesson. Our main goals will be to find what we call coterminal and reference angles. And really, these reference angles you will use the rest of this unit. So it's really, really important that we can pretty quickly identify and find reference angles. In geometry class, you were given a definition of an angle. In geometry class, an angle is simply two rays with a common endpoint. Two rays with a common endpoint. Our definition of what an angle is in trig is slightly different. What we define an angle to be in trig, we do have a ray still. We still have that ray, but what the angle is an angle of rotation. So we're taking that ray and we are rotating it around that endpoint. So here's the rotation. And then where that ray ends up after the rotation is the other part of your angle. So it's a ray rotated around that endpoint creates what we call the angle of rotation. You will see that Greek letter theta used again as your angle of rotation. So when you see that, just understand that's your angle of rotation. Okay, take a look at this graphic that I have for you. So similar to what I just said, that ray that I started my last drawing with, that's what we call the initial side, initial meaning start. After the rotation, the ray that you have is what we call the terminal side, okay, terminal meaning the end. When your initial side lies along the x-axis, which it does here, this is what we call standard position. Okay? So initial side is where it starts, terminal side is where it ends. When your initial side lies along the x-axis, we consider that to be standard position. So, what these fill in the blanks are is essentially what I just said. The initial position of the ray is called our initial side of the angle. The final position is our terminal side. And then our angle is in standard position when the initial side is positioned on the x-axis. All right, what you hopefully recall from geometry, in a rotation you can rotate clockwise or counterclockwise. If your direction of rotation is counterclockwise, so if you look over in this graphic, if your angle of rotation is counterclockwise, your angle has a positive measure. if your angle of rotation is clockwise, so take a look up at the graphic here. So if this is our initial side and we are rotating clockwise, you can see that your angle will have a negative measure. So the red was the counterclockwise and the green was clockwise. We hopefully know that the common unit for angle measure is our degree. And a complete rotation would be forming a circle of 360 degrees. What I want you to just look up here for me. Look at with this graphic. There are actually two angles of rotation here. Okay? There's the positive angle of rotation when you're taking that terminal side and rotating it counterclockwise. There is also the angle of rotation taking that that initial side clockwise over to the terminal side. Both of these angles of rotation have what in common? Okay, they do add up to, well, the absolute value of them add up to 360. Alyssa, what did you say?
They have like the same initial
They have the same initial side. What else?
and the same terminal.
Yeah, they have the same terminal side. Okay? They both start at the same place. They both end at the same place, but the angles are different. Okay? Give me 1 second. These two angles are what we call coterminal angles, meaning they have the same terminal side. Okay, so once again, these two angles are what we would consider coterminal angles. They have the same terminal side. I think that's what I just said for number 5. Coterminal angles are angles in standard position. They are coterminal if they have the same terminal side, is what I should say. Okay. So notice, coterminal angles, one will have a positive degree measure and one will have a negative degree measure, okay? It says to find the coterminal angle theta for each angle below so that our coterminal angle is somewhere between negative and positive 360. All right. So here's what we're going to do. We are going to take the angle we're given, we are going to add 360 degrees to it. We are going to take 90 degrees and we are going to subtract 360 degrees from it. Why am I doing that? Why am I adding and subtracting 360? What's the significance of that?
Because they're coterminal, right? Because they go both ways.
They're coterminal. So,
Is it for the clockwise and counterclockwise?
okay, so one's going clockwise, one's going counterclockwise. If we want to end up, let's say for this one, if we want to end up at the same place, we can do one rotation going one way, one the other way. Now, the stipulation that we have here is that our coterminal angle is between negative and positive 360. So the problem with adding 360 would be that we're beyond our interval of positive to negative 360. So we're going to discard that angle measure, and we are going to take the other one. So the 90 minus 360 is a negative 270 degrees. If you want a visual of this, so here's our x and y axis. Here's my initial side. An angle of rotation of positive 90 degrees would be right here. Yes, up to the y-axis. Right? So this was a positive 90, and then a negative 270 would be going all the way around and ending up with the same terminal side. Yeah? Okay. That 90 plus 360, that would be doing this. That would be going from here, going all the way around again. It is a coterminal angle. It's just not within that interval of negative 360 to positive 360. On the next example, same type of thing. We are going to take that negative 27 degrees. We will add 360. We will subtract 360. What did we get for the first part? 333 degrees. And what about the second one? Negative 387. Keep in mind we have this interval of positive to negative 360, so we need to cross out the second one. And that first 333 would be our coterminal angle. All right, Lydia, for part C, what is your coterminal angle between negative and positive 360? No, the coterminal angle. 175. Okay. Mika, what about for D, your coterminal angle between negative and positive 360? For part D, what did you get? Negative 237. Good. Any questions I can answer on that? You good? Kelly? Mm-hmm.
You have to do the other one.
Okay. For any angle theta in standard position, again, standard position is where your initial side is on the x-axis, what we call the reference angle, and that's denoted by a theta with a subscript REF. Theta subscript REF for reference. This is the positive acute angle formed by the terminal side of theta and the nearest part of the x-axis. I'll say it again. It's the positive acute angle, so it's always going to be positive and less than 90 degrees. That's formed by the terminal side and the closest part of the x-axis. So, let me go through a couple of instances here. So, take a look at this for me. First of all, the black angle here is showing you your angle theta. So it's taking, and what I typically do is highlight reference angles. It's taking the terminal side and then the closest part of the x-axis. So what I mean by that is from where the terminal side is, this portion of the x-axis is closer to that than this part is, right? Yes? This is obtuse, this is acute, so this part has to be closer. Does that make sense? Terminal side, closest part of the x-axis. In this example, here's your angle theta. Here's my terminal side. Closest part of the x-axis is here. So notice that your angle theta and your reference angle could be the same angle. Okay, it could be the same angle. Here's our angle theta this time. It's that real big obtuse angle. I'm taking the terminal side, closest part of the x-axis. One last time. An even bigger angle theta. I'm taking the terminal side, closest part of the x-axis. Okay. Terminal side, closest part of the x-axis. That will give you your reference angle. Okay. Let's look at some examples now that are more specific. It says to find the reference angle for each angle given. Our first job here in all of these examples is to get the actual angle theta sketched out. So you really need to be aware of where the different degrees are. So let's go through that real quick, because that is going to help you out. So think about this as being 0 or 360 degrees. This would be 90 degrees. This would be 180, and then this is 270. So just kind of use those as reference points as you draw in these different angles. So 94 degrees, we're always going to start our initial side on this x-axis, so we could draw this in. So if you think about a 94-degree angle, if this is 90 degrees right here, 94 degrees would just be, and it's not going to be perfect, but, you know, get it somewhat where it should be. 94 degrees there-ish. Okay? That's probably a little too far, but... So that's our angle theta. That's theta. What we're looking for is the reference angle. So we're going to start with the terminal side. Start with the terminal side. And then which part of the x-axis is closer to that? No, that's the y-axis. Yeah, where we have that 180. It's the x-axis. The x-axis. So what I have in red would be your reference angle. But now the question is, what's the actual measure of that?
180 minus 94.
It would be 180 minus 94, exactly. Which is 86 degrees. And you can really think about finding the measure of these reference angles in a variety of ways. I mean, if you want to think about it as from this terminal side, I've gone 4 degrees. You could take 90 minus 4. That would give you the 86. There's a variety of ways to think about finding that angle measure. But all right, let's look at the second one then. Our angle theta that we're given is 240 degrees. We're going to start our initial side on the x-axis. Remember that this is 180. This is 270. Again, just use those values as kind of a reference. So 245 would be, I don't know, there-ish. A little bit closer to 270 than 180. Yeah? So now we need to draw in the reference angle. Start with the terminal side. Start with the terminal side. And then the closest part of the x-axis is where? What? Exactly. Now, how do I find the measure of that? How can we find the measure of that? 245 minus 180. Alyssa, how are you getting this quickly? Because other people might not.
I don't know.
Claire?
This isn't gonna happen.
All right, so when we take that 245 minus 180, I'm getting 65 degrees. Is that reference angle? Remember that reference angles have to be positive and acute. They also have to be acute. So if you're getting an angle measure that's not acute, you did something wrong, okay? Let's do one more together. So we have 290 degrees. Again, we're going to start our initial side on the x-axis. 290 would be, I don't know, right there about maybe. Okay, our reference angle is the terminal side and then the closest part of the x-axis, which is where? 360. The 360. Okay. So it looks like we went on top of our original angle, but it's going the other degree, the other way. So how can we find the measure of this guy? Yeah, you could do it that way, sure. Yeah, you could certainly do 360 minus 290. Anybody do that differently? That's how you guys do it? Okay, yeah, that works. That would be 70 degrees. Okay, take a minute with your table and look at, oh, the last one. That's got a negative theta measure. Try it.
Why don't you just go?
Okay, so negative 110 degrees. I don't know, is that what's throwing you off maybe? Okay, you're still going to start your initial side right there on the x-axis. Negative 110 is where?
It's like the lower left.
Think about this. I know I told you that's 270, but that could also be what?
90.
Negative 90. Negative 90. So negative...
Think about it.
All right, so negative 110 is just past that negative 90. The reference angle, again, is your terminal side and the closest part of the x-axis. So how can I find that guy's measure?
Is that still 180 or is it now like negative 360?
Well, it would be negative 180.
Okay, so you don't swap the x-axis.
Because if you're going this way, that would be negative 90, that would be negative 180, negative 270.
Okay.
But remember, your reference angle is always going to be a positive angle measure.
So if it's negative, then everything like it's flipped around.
Okay, we still need to find the measure of this guy.
Is it 180 minus 110?
You can do it that way, yes. 180 minus 110 would be 70 degrees. I know Sydney talked about doing it differently, guys. There's more than one way to find these reference angles, but I think you kind of are